Okay, so formula form is fairly straightforward, right? We're just going to say impulse. And the symbol we use for impulse is actually going to be J. Force times time. That's it. J equals force times time, Ft. Okay? What would be the units here? Yeah. It is. What are the units here for force?
Units. Seconds.
Okay, Newton seconds. So our units for impulse would be Newton seconds. Notice again, impulse is 2. So the greater the force, greater the impulse. The greater the time, greater the impulse. Okay, let's expand this a little bit. Let's keep going. So one of our big equations for the year is F equals ma. Let's go ahead and substitute that in. So we could also write impulse as mat. Another one of our big equations for the year is one of our kinematics, Vf equals Vo plus At. If we rearrange that, we get Vf minus Vo equals At. Okay, notice here we have our At, right? So let's make the substitution for At. That's going to equal m times Vf minus Vo. If we distribute this m to both sides, to both terms, both velocities, we get mv final minus mv initial. Well, what do we call m times v? Momentum, right. So we could write this as P final minus P initial. But what is P final minus P initial? A change, yeah. Final minus initial is, we call that a change. So, change. So not only is impulse equal to force times time, impulse is also equal to the change in the momentum. So let's look at some concepts with this. If anyone that's ever played sports before, probably, like if you played a hitting or a kicking sport, your coach tells you when you hit the ball, don't just hit it, follow through when you hit the ball, okay? Or when you kick the ball, follow through when you kick it. Well, why are they telling you to follow through? So, for example, if the ball comes in, you're not just going to swing the bat and stop like that. You're going to swing the bat and follow through with it. Well, what are you changing when you're following through? The time of contact, right? You're increasing the time of contact. Well, by increasing the time of contact, what happens to the change of momentum? What happens to the final velocity? It increases. So by following through, you're able to exert a greater impulse. Even if the force is, even if you kick it the same or hit it the same, you increase the time of contact, greater change of momentum, greater final velocity. You hit the ball farther, you kick the ball harder, and so forth. Okay, let's look at another concept. What if you were to, let's say, jump off a roof? It's always a good one, right? It's like he's peeing off the roof. Alright, so say you're going to jump off a roof, right? So how should you land?
On your head.
Okay, is that a good thing? How about with your feet? So one option of landing is to land, to lock up your legs and to land like that. Okay? So that's one option to do it, right? Another option is to maybe bend your knees like that. Or a third option might be to kind of bend and roll. Okay? So what's going on here? Which one of those three options, locking your knees, bending your knees, and kind of tuck and rolling, which of those is exerting a greater impulse?
Without touching.
Because the rolling there's going to be more time, so it would be like a lower impulse. Or I mean, it would be greater change.
Okay? So I'm kind of trying to mess with your mind a little bit. What's true about the impulse? So the impulse is change in momentum. So which one has a greater change in momentum? They're all the same, okay? The impulse is the same on all three because they're moving a certain speed. Maybe you're going 10 meters per second and then you stop. 10 meters per second and then you stop. In all three cases, it's 10 to 0, 10 to 0, 10 to 0. So the impulse is actually the same in all three cases. However, what we care about in terms of our body and not breaking things is the force. Which of those is exerting a greater force? Locking the knees. Because, look at the time. Even though the change in momentum, the impulse are the same, if the time goes down, what happens to the force? Oh. If the time goes down, what happens to the force? Force increases. So by increasing the time that it takes you to slow down, you're decreasing the overall force. You need less force to stop in the longer period of time. Okay? All right, let's go.